this video is about linear modelling. So linear modelling is a really important part of the applications and interpretations course. Well, not just linear modelling, but modelling in general. Modelling is when we take experimental data or any bits of data that we don't know whether they're linked or not, and we're looking to see whether we can describe it using maths. So at the moment we're looking at linear functions. So at the moment, at this part of the course, they will all be linear models, so they will form a straight line graph. But that won't always be the case, because we're going to learn about other types of models, other functions that can be used. This is just the first step. So when we are modelling, this isn't walking up and down on a runway looking good. It is about finding a mathematical equation that helps us to fit the data, so to model the data, to represent the data. And the way we do that is we use our GDCs, our calculators, graphical calculators, to plot the experimental data, and then we look at the graph and we decide what function it looks like, which one it's more likely to be. And then from that, we're then able to use our calculators to find an equation that best represents that data. Now, I've made a separate video that's about using the Casio calculator, and there's more help in the textbook on this button here for other calculators. So, plot the graph of this data on your GDC. That's the first step when we look at this. So we do that, and then we look at it, and what we see is it's a nice straight line. The points line up. So we're then able to use our calculators for the model. This bit here, where it says determine a reasonable domain and range for your model. This is always the data you're given. So it's the domain will be between 4 and 10, and the range will be between 130 and 369.2. When we plotted the equation on our calculator, we got y equals ax plus b, and we were given values for a and b. They turned out to be these, and you can see we can write it like we do with straight line graphs, y equals mx plus c. You can round these numbers to 3 significant figures. You can leave it like this. Obviously, it's better to round at the end of a question. Then the domain and range we write like this. This is important, this is asked, because this comes into these predictions here. When we were looking at the calculator, we looked at how to find each of these answers, and for 4.5 it gave us 150 degrees to 3 significant figures, and this one gives us 769 degrees to 3 significant figures. So these happen according to our model, and the 4.5 is a legitimate prediction to make because it's within our data. It happened between 4 and 6, but 20 minutes is well after the end of our experiment. We don't actually know if the model still fits above 10 minutes, and so we can't say that this is valid. We say it's extrapolation when you go outside of the data range. Extrapolation. So 20 minutes was not included within our data, so it can be risky to use that as a prediction. 20 minutes is not within the domain, so this is not a valid prediction. And that is one of the most important parts of the modelling, is that we can only use data that's within the domain that we've been working in. We can't make predictions outside of the domain, it's not as valid.